All right, good morning. Hope everyone's doing well. I apologize for the last lesson with regards to the technical issues. I think I have them resolved, so we shouldn't have that problem today. I kept messing with the streaming settings to try and make it better, and each time I messed with the settings, it got worse. So then I just turned everything back to the defaults, and then it works fine. So I think the lesson is just don't mess with settings I don't fully understand. Good morning. Wait for one more person to join in. All right, cool. So, good morning, everyone. Today we are going to talk about something called pseudocode. So, what is pseudocode? Basically, pseudocode it's it's a way of writing an algorithm that is language independent. So basically, no matter which programming language you specialize in, you should be able to just read pseudocode and kind of get the idea of what's happening. Okay. So it's a way of describing algorithms that's language independent and easily understandable. So I'll just put easily readable, regardless of the language that you usually would use. Okay. And so I'll give you an example. This is a textbook that I have on algorithms. This is a very famous textbook in computer science. I haven't read the entire book yet, but because it's obviously, over 1,000 pages, but and I like to spend most of my time reading about physics. But anyways, so I have a page here that I found that has some pseudocode on it. So let's take a look at it. So you can see that this is pseudocode right here. And so pseudocode is, this isn't written in any particular programming language. But you can figure out what the author is trying to say. Okay, so it's an algorithm of 3 methods, it looks like. 3 methods, and it's not written in a particular programming language, but we can still understand it. Okay, that's because this textbook is not a textbook about a specific programming language. It's just about algorithms in general. Okay, so that's how pseudocode works. That being said, this is IB Computer Science, so there aren't really any strict super strict rules for pseudocode because you're just kind of trying to get your idea across. But IB has some conventions for pseudocode. So there's a document right here, which, pseudocode and examinations. And so how I found this document is I just typed in IB pseudocode rules or something like that. And there's a document that just gives, a bunch of conventions for pseudocode. Okay? So that's basically what I'm going to be going over today is how to do pseudocode in the IB way. All right. So, and then I'm going to go over a couple of algorithms that I wrote in pseudocode. So first of all, I'm going to just talk about the elements of pseudocode. So you can have comments, just like in Java. And the comments, you're going to have comments with double slashes. Okay, so that one is exactly like Java. The IB pseudocode has a limited list of variables compared to other programming languages. So really, you're only going to have use for the following data types. You could have integers. You could have Booleans. So that's true or false. You could have strings. Or you could have arrays of these. Someone is blowing up my phone, trying to figure out what's going on. All right. Now, when you define a variable, unlike Java, so with Java you would say int x equals 5. But in the IB pseudocode, you don't have to do that. So you have no type declarations. So you would say, for example, you might say just like x equals 5. And then you're supposed to know that just based on that is an integer data type. So it's kind of like, it's a bit like Python in that sense. Python, you don't declare a data type, which I despise. I mean, I like Python, but I like to know what the data type is when I'm doing my code. I like to be explicit about that. You could also say, like word equals hi. Okay, so that would be defining a string variable. One of the things about variables is that the variables are in all caps. I'm not going to type out, or I'm not going to write out capital, because is it AL or is it OL? After last week, everyone's flipping out. Does capital have an A or an O? In which situations? Oh my gosh. And you could also have arrays of these various data types. And arrays are going to basically be defined as a comment. So you would say like my array is an array. I don't know, something like that, of size blank. Okay? Oops. So there are a number of array methods. Okay? So let me talk about the array methods. And they're a little bit different from the way it works in Java. Okay? So there is a method called add item. Okay, so an array is almost more like an array list where it has a variable size. So you can add an item and you would put the thing that you're going to add in the parentheses. So you would, for example, you could say array dot add item 7, something like that. You can only add it to the end. All right. Then there is a get next. So this will do the obvious thing of returning the next element in the array. So this is useful when you're iterating all over the array. You just repeatedly do the get next. Okay. There is a reset next, which basically goes back to the beginning of the array. There is a has next method. So this would tell you once you get to the end of the array. So has next would return false if you are at the end of the array. And then there is an is empty. Okay, which would return true if the array doesn't have any elements in it. Okay, so those are arrays, the various methods of arrays. You can also have stacks, which we talked about. So stacks, you will recall, have 3 basic operations. They have push, they have pop, and they have is empty. Okay. You also have queues, which have some methods such as enqueue, dequeue, and is empty. All right, so I guess I should say you can have integers, booleans, strings, arrays, stacks, and queues. I should have said that. So let's talk about control structures. So when I say control structures, I mean if-else statements, loops, things of that nature. Your control structures are going to be written in lowercase. So the variables are in uppercase, the control structure statements are in lowercase. So you have flip the page here. So for your control structures, you have if statements, of course. So you have if blank. Now in Java, you would just say if blank, and then you'd have some Boolean expression, and then you have your code. But a lot of programming languages do if blank, then do this. So that is the pseudocode notation that Java uses. You do some stuff. Maybe you have an else if blank, then you do some stuff. Else, do some more stuff, and then you have end if. So this is something that's a little bit different as you put the end if in there. Okay. You can do loops. So for loops, what you would do is you would say loop. This would be a what do you call it? A for loop. So loop, maybe you want to loop n from 0 to 47. So this would loop 48 times. Okay, notice how the control statements are in lowercase, so from to loop. The variable name is capitalized. You do blah, blah, blah. And then you end the loop afterwards. So this is a for loop. You could also do a while loop. So loop while something, do some stuff, and loop. Okay. You have, and so yeah, there's no switch statement or anything like that. You have an output statement, which is basically like print to the terminal or return in a function or a method. And a final pretty important point is that you can pretty much make up your own stuff if you need to. If it is clear. So, you could provide comments and then just say like, let function f be a function that does blah, blah, blah. Okay? And then you could use that function. So let's look at a couple of examples of pseudocode that I wrote this morning. All right, so here's an example. Hopefully you can see the whole thing. Cool. Sometimes in pseudocode they number the lines, but yeah, I'm not going to do that. So let's suppose that survey is an array of survey results. Okay, so it's an array, and each element of the array is either yes or no. Okay, and so what we're trying to figure out is, does the survey pass? Do more people say yes than no or not? All right. So basically what I want to do is I want to iterate through the array, and I want to count up all the yeses, and I want to count up all the nos. Okay. And then I want to compare them. And if the yeses are more than the nos, then it passes. So first of all, I'm going to define some variables, yeses and nos, and I set them both equal to 0. Okay. So because I haven't started looking at the array, at the survey results yet, so I'm gonna set them both to 0. Then I have survey.resetNext. So if you recall, the reset next, make sure you start at the beginning of the array. So now I have loop while survey.hasNext. So hasNext returns a Boolean that is true if there are more elements in the array, and it's false otherwise. So basically what this is going to do is it's going to go through until I get to the end of the array. So it's similar to a for loop, but in Java when we do a for loop and we go through an array, we use the array.length field to get how far. But in the IB pseudocode, you just keep going until it doesn't have a next. All right. So then I define the response, which is survey.getNext. So I get the element of the array. And if the response is equal to yes, then I increment yeses by 1. You could probably get away with saying yeses plus plus. All right. Otherwise, the response must have been no, so then I'm just going to increment no's by 1. Okay, so depending on what that particular result is, I increment either yes or no, and notice how I have my end if statement. And then I have my end loop statement. So getNext is going to automatically go from element to element. So it's not like a for loop in Java where you have to increment I each time in the loop. Okay, it's automatically doing that with getNext. So now I have yeses and no's. So after I've completed this, I have yeses and no's in different amounts. Okay. And then I just have a final if statement that says if the number of yeses are greater than the number of no's, then we're going to output passed. Else, we're going to output no pass, or I don't know why I put no, and then end if. Okay? So this is going to tell us, did the motion pass or did it not pass? So that's an example of writing an algorithm in pseudocode. Do one more. So here's another one I wrote. This is a queue, and it's going to reverse the queue. Okay, so if you recall, a queue has 1, 2, 7, 4, 9, and so this is the front of the queue, and that's the end of the queue. So we want to reverse the order so that it's 9, 4, 7, 2, 1. Okay, so Q1 is an input. Q2 is an output that is initially empty. So notice how at the end of the algorithm I output Q2. And I'm going to use a stack. ST is an empty stack. Okay. So I said loop while not Q1 dot is empty. So basically I'm going to go through the entire queue until it's empty. And then I'm going to take my stack and I'm going to push the front element of the queue. So I'm going to dequeue Q1 and I'm going to push it onto the stack. All right. So basically what that's going to do is, let's say that's 1, 2, 7, 4, 9. I'm going to go through and I'm going to take the front element and put it onto a stack. So it's going to take it and go to 1, 2, 7, 4, 9. where here's the bottom of the stack. Okay, that's what this block of code is doing. Then I'm going to loop while the stack is not empty. Okay, and then I'm going to enqueue into the second queue the top of the stack. Okay, and I'm just going to keep doing that. So basically I'm going to enqueue a 9, then I'm going to enqueue a 4, then I'm going to enqueue a 7, then I'm going to enqueue a 2, and then I'm going to enqueue a 1. So you can see that that has reversed the direction, or it has reversed the queue. Okay? So that's kind of a superficial example, but the reason I did that is just because I wanted to show how you would use some of these other methods. If you look at that document that I told you about, it has a couple of examples that you can take a look at if you're not understanding this lesson. So in particular, it has the pseudocode for averaging an array. Copying from a collection into an array, finding factors, copying a collection into an array in reverse. So there's a couple of different examples you can look at if you did not understand what I said. So that is my lesson for today, folks. And so I will see you in the Zoom room. Bye for now.